In this video, we're going to take a quick look at one of the applications of enolates, and that is the haloform reaction. Earlier in this chapter, when we were looking at reactions of enols, we saw a reaction that could be used to halogenate alpha to a carbonyl, and this actually proceeds through the enol, and then it leads to the alpha halogenation product. So alpha to the carbonyl, a halogen is now connected. So a halogen has replaced one of the hydrogens. This reaction involved acidic conditions, and experimental evidence has shown that it proceeds through an enol. Now that we are talking about enolates, is it possible to do an alpha halogenation of enolates? Well, let's imagine we have a ketone and we treat it with a strong base such as LDA. That is going to pull off, for example, one of these protons, and that will give us an enolate that looks like this. Now this can react with bromine so that these electrons attack here, kicking away Br- as a leaving group, giving us this. So we can make essentially the same product under basic conditions as we could under acidic conditions. But one of the problems that we have under basic conditions is that while this molecule was much less reactive than the starting material, this compound is more reactive than the starting material. And so under basic conditions, we end up with multiple alpha halogenation so that all of the alpha hydrogens are eventually replaced by a halogen. So synthetically, this isn't really very useful. But traditionally, there was a very important application of this, and this is called the iodoform reaction. So let's say we have, for example, a methyl ketone, and this can undergo alpha halogenation under basic conditions, and this is going to give us some of this. Now, once this reaction has happened, this set of hydrogens is even more acidic, so it is happy to react again, giving us some of this. And then this can react again, giving us some of this. Now, this one can undergo nucleophilic acyl substitution, where these electrons are going to add here. These electrons will come up, come back down, and kick out the Ci3. That will give us this plus our CH2 C double bond O OH from this side over here. And then an acid-base reaction will give us our final product of HCI3, which is called iodoform. And we make a carboxylate. So actually, we don't even care about the carboxylate. What we care about is the iodoform, because this gives us a yellow precipitate. And so this can be used In structure determination, if we're trying to find out whether we have a methyl ketone, then we would look for the formation of a yellow precipitate, which corresponds to iodoform, which tells us that yes, we must have started with a methyl group adjacent to our carbonyl. Think about some of the experimental work that you carried out with the unknown experiment when we couldn't just determine the structure by IR or NMR, and you had to carry out reactions and interpret the evidence. So the iodoform reaction is something that used to be very, very important for structure determination. And I just want you to be aware of the usefulness, or I guess the former usefulness, of this type of reaction.